Hello everyone, I'm Balitara Kutanarivu. Today, I'm going to present you with U-spaceChain, a decentralized approach using blockchain to provide traffic management services to drone or unmanned aircraft systems. This work was done in the Enac Airbus Suprasteria Drones and UTM Research Chair with murat bronz. Drones are interesting because they allow humans to complete dull, dangerous and dirty missions at a lower cost compared to manned aviation. Moreover, we now see an increasing drone traffic volume of operation worldwide. It raises global questions regarding the safety, security, environmental impact, and social acceptance, not only for each drone operation, but also for a large number of drone missions or drone traffic. The answer lies in regulation, which, among other things, require unmanned traffic management or UTM. Although blockchain is a good candidate for UTM, the problem is that no implementation available to the operational people or researchers conforms to the regulation while being usable to provide the required UTM services and simulate future traffic. So, our research questions are: can a practical blockchain-based system provide regulation-compliant services to support UTM? And if so, how? We use the system development methodology to answer the previous questions. In short, the answer is yes, we can, as we propose theoretical contributions which were implemented and validated through simulations on a proof of concept software. I will now provide more details about the paper's method and contributions before discussing the limits that can foster future research directions. From the state of the art, researchers and operational people have started initiatives to adapt and digitalize information management in aviation to overcome the capacity problem and increase the safety and security of air traffic management, which includes UTM. Blockchains are a potential solution, and some work for drone operation has already been published. They prove that blockchain can be used to manage and secure drone traffic. However, they were predominantly used to bolster security aspects, and no work was done to provide several services within a defined regulatory framework, agnostic of the type of operation in which each drone could have its own independent mission. The aim is to build and validate a proof of concept for blockchain-based regulatory compliant services provision for UTM. We use the system's development methodology from Nunamaker, Chen, and Perdin. Not only does it allow the development of a system that serves as a proof of concept for fundamental research, but it also provides an artifact that could become the focus of further research. Finally, we validated the behavior of a resulting software through simulations. To reduce and control the scope of application to achieve concrete implementation, we base the requirements for our system on the European regulatory framework for drones. It encompasses the U-space concept, which consists of a set of new services and specific procedures designed to support safe, efficient, and secure access to airspace for a large number of drones. Among U-space fundamental principles are minimizing deployment and operating costs, providing scalable and flexible systems, and adopting technologies and standards from other sectors. The European regulation defines rules for participants in drone operations. It requires 4 services to be relied upon by operators flying in U-space airspace. U-space service providers must provide the services: geo-awareness, flight authorization, network identification, and traffic information. 2 other services are optional: weather information and conformance monitoring. The regulation also includes another service, the common information, which allows injecting classic ATM operational data into the UTM world. Now, let's detail the contribution. The literature already proposes distributed UTM architecture with direct peer-to-peer between drones. Instead, we propose a blockchain architecture in which the USSPs are connected peer-to-peer, the operators are connected to their chosen USSP, and the drones are connected to their operator only. This flexibility not only considers the different participants' roles, but also supports various scenarios, such as when the USSP is the sole provider of specific service, or the closest, or due to other preferences. In addition, the USSP blockchain, also called U-spaceChain, allows other stakeholders, such as the public and authorities, to access some of the data. Another contribution is the concept of services as smart contracts. Smart contracts are computer scripts that allow autonomous computation, guided by rules and policies, while automating previously manual business logic. Some benefits are risk reduction, reduced service and administration costs, and enhanced business process efficiency. We had to describe, design, and classify different variations of smart contracts to allow the automated provision of the services required by the European drone regulation. Let's imagine an operator who wants to fly a drone in a U-space airspace. She will need to rely upon the different services. We will use that common thread to explain both the services and the corresponding smart contract types. Geo-awareness service should provide operators with information about the latest airspace constraints and the defined UAS geographical zone information constraints. The operator uses it to know where she can fly and under which conditions. Here, the information is updated according to events and does not concern an identified flight. This case is the most straightforward service, so we identify it as a static service. The operator needs to access weather data during flight preparation and in flight. Weather information service injects weather operational data from messages like airports METARs. Common information service injects operational information from the outside world, like position of closed manned aircraft. They share the same core principle. Information from an oracle is updated periodically and the blockchain must be updated. We identify it as an imported service. The operator will need an authorization to fly. The flight authorization service should grant the individual flight authorization. It concerns each identified flight and can consist of one or more steps. Either one request when the current blockchain data is enough to immediately produce the answer, or forwarded to another entity for further coordination. During this process, several loops between the operator and the safety officers may take place until the authorization is granted. Sometimes, the request is waiting for answers from the safety officers, making it asynchronous. At that final stage, the information regarding this operation will not be updated anymore. We identify it as an asynchronous service. During the flight, the operator needs to send some of the drone's data to the USSP, such as its identity, its geographical position in 3 dimensions, and so on. Network Identification Service supports the continuous processing of a drone's remote identification throughout the flight and shall provide it to authorized users. The data concerns each identified and authorized flight. Each transaction has no relationship with the previous or the following ones for each flight. However, they are repetitive, as the data should be sent periodically as long as the flight plan is active. We identify it as a repetitive service. The operator needs to be aware of the surrounding traffic situation. Traffic Information Service shall contain information on any other conspicuous air traffic near the position or intended route of a UAS flight. A Conformance Monitoring Service shall enable the UAS operator to verify whether they comply with the airspace requirements and the terms of their flight authorization. The TI and CM are sent to each flying aircraft, resembling the NI. The services are not only repetitive but also dynamic. They are executed as long as the flight plan is activated, using relevant data in the blockchain to feed their algorithms and achieve the desired outputs. We identify them as dynamic services. Another theoretical contribution is the appointment by authority mechanism. The context is a permission blockchain. The assumption is that no participant will purposely send corrupted data, as each participant must go through a certification process before being accepted as USSP. Safety and operational efficiency take priority. We propose a consensus mechanism in which the authority publishes a list of nodes that can create blocks. That list can be updated and published anytime on the blockchain. This leader node will retrieve a transaction from each registered node before creating the next block. From the chosen method, a working software that behaves as expected for a determined scenario can validate the proof of concept. We build a prototype that implements the theoretical contributions in order to validate the proposed concepts. We wrote the USSP software or node from scratch in JavaScript. The simulated system has 3 nodes, representing 3 USSPs connected to 6 operators. We set the blockchain time step for synchronization to 4 seconds, meaning the system will add a new block every 4 seconds. The scenario involved 1 hour of traffic, during which 30 drone flights were created and performed. Each drone's minimum flight time was 5 minutes, and the minimum distance flown was 900 meters. To test for CM, 10 of the NI transactions of 3 of the flights were modified to trigger the CM notifications. We ran the test scenario multiple times. U-spaceChain requires data to verify the system's functionality with continuous and timely transaction feed. Thus, we have developed enabler scripts to support the system's testing by simulation. Here are the results of 6 runs. The count of CI, GO, TI, and CM execution correspond precisely to the expected values. The FA, NI, and WE were mainly coherent with their expected value, with some variation. For 2 simulation runs, WE had 0 added transaction as the nodes were intentionally disconnected from the internet, prohibiting the insertion of weather data into the blockchain. While we reached the goal of validating the concept, the number of invocations of repetitive and dynamic services could sometimes have been more accurate due to the implementation of the enabler used for orchestrating the simulation, which we can improve later. I'll discuss the results. From a security point of view, the blockchain is a promising approach to providing UTM services. In the future evolution of U-spaceChain, smart contracts can encrypt data before it is written to blocks to guarantee confidentiality. Because of its immutability, the integrity of data is preserved. For availability, as access by different stakeholders is expected, external consultation should be possible, using different endpoints to segregate the information viewers and close up the sensible data. Each U-spaceChain node exposes API endpoints and web pages from which external consultation is possible. For extensibility, the services as smart contract structure is designed to lower the difficulties of creating new services. The diverse types of smart contracts to inherit allows us to handle most cases. We successfully mapped over drone services proposed in Chorus to our smart contract types. For generalization, every domain where a permission blockchain is adequate could be a potential application. All domains where an authority wants to let the market thrive while maintaining light control may use the ABI, appointed by authority consensus mechanism, if participants are mostly sure to behave correctly, such as after a certification process. Now I'll explain some limits while indicating future directions. This proof of concept did not tackle the issues of performance. Performance metrics remain an open question regarding U-space, as a blockchain's performance and traffic safety must be combined. The value of essential parameters has yet to be discovered. For example, the correct duration before U-spaceChain synchronization impacts the NI and TI and CM services, calling for further study to find the correct number for future operational needs. The concepts were used on a blockchain developed on purpose. In this proposed implementation, services such as smart contract cannot be loaded on top of blockchains like in Ethereum. They need to be part of a node's source code. Research regarding improvement in services such as addition or updates of smart contract without restarting the whole blockchain can be beneficial for security and operational continuity, or implementation of a proposed concept with other blockchain frameworks is needed. Appointed by authority is not yet a complete consensus mechanism. Although it allows U-spaceChain to work effectively within the prototype state scenario, its performance and security aspects still need to be studied more. U-spaceChain should not be a cold data repository. Off-chaining and decentralized file system could be envisioned for better scalability and performance to enhance U-spaceChain. Such concept will add more storage capabilities while retaining all the system's qualities. This paper investigated how to provide UTM services that are compliant with a regulatory framework in a decentralized approach. U-spaceChain is based on the European Drone Regulatory Framework, but can be translated into other drone regulations. Its conceptual contributions include the blockchain-based architecture associated with the services as smart contract and the appointed by authority consensus mechanism. The practical contributions are a proof of concept and 4 enablers allowing system simulation. It is positioned to serve as a valuable reference, providing the basis and insight for applying blockchain in the UTM domain. The future directions are to establish a performance metrics and study its consensus mechanism scalability and security. Thank you for viewing this presentation. Please feel free to reach out if you have questions.